Hi, welcome to our project presentation. Our project offer report is a suburb-based discount and money-saving information database. Our business model is very simple. Local business owners record data into the database, and the local residents can search for latest information. Our report provides following key features: user login and logout, along with Google account quick login. Once registered and logged in, user can record discount information into our database. User can use current geolocation to check nearby discount information or manually input the suburb to search, along with product or service keyword search and industrial category filter. After logging, user can also subscribe to the business or quickly check latest discount information from user subscribe business. For each record, we support text and image gallery and video player for multiple media presentation, which ensure to maximize information delivery capability. This is the diagram of application structure, including both front end and back end, UI library, database, image storage, cloud service, and code quality control. And we also use Google Maps API to get users' current geolocation, such as current latitude and longitude and current address information, along with dynamic map of business address loaded on the discount details page, and the Google Auth for third-party login, and Stripe for payment gateway. For performance optimization, we conducted certain image optimization methods, like set upload image size limit and compress image before uploading, convert image format from JPG or PNG to WebP, and use lazy load to enhance user experience. And by our testing, the optimization result is that we reduced the upload image size up to 73% and reduced page loading data volume up to 69%. And since we didn't use Next in this project, we also put some efforts on SEO optimization. By using React Helmet, we can set a meta for each page. And more importantly, we can use post title and post text content directly as variables to set page description and keywords. I will show you guys the real application demo later on. Next, let's welcome DevOps team to introduce DevOps architecture in this project.
Yeah, thanks, Alex. And hello, everyone. And my name is Charles, and I'm the DevOps engineer in the Dealin team. Next page. Yeah. Now, let me give you a brief walkthrough of the system from 3 different perspectives. Next, please. Yeah. First one, user traffic flow. So you can see now it's presented in the black line in this diagram. Our system adapts the classic front-end plus back-end architecture. So here we can see at the bottom left is our front-end part. So generally speaking, a user request will first reach route 53, which will redirect it to either front-end or back-end service. For the front-end request, it will be redirected to the CloudFront CDN, which will cache all the static pages from S3 bucket destination. For a backend request, it will go through the backend internet gateway and then be passed to application load balancer to handle. The middle part is our backend application hosted on AWS EKS. For the maximum security, all workloads are deployed in the private subnets and only accessible through the application load balancer. You can see it in the middle of the diagram. And then lastly, at the far right side of the diagram is our database using a fully cloud-based MongoDB service. We created 2 instances to serve our UAT environment and production environment. Next, please. Yeah, this diagram shows the log and metrics flow, and here you can see the both network traffic and EKS logs are exported to the CloudWatch and then visualized in Grafana. When pod metrics in EKS is above the preset threshold, an alert will be triggered by the AWS NS service to notify the on-call staff. Next. The last diagram demonstrates our CI/CD process. We use Jenkins for our front-end and back-end pipelines. For the front-end, the code will generally go through the installation, unit testing, and code scanning stage, and then eventually will be pushed to S3 bucket. And after that, it will trigger a CDN caching validation to clear the caching. For the backend pipeline, the code goes through the similar process, but build a Docker image instead. The Docker image will be pushed to the ECR to store and also deploy to the EKS nodes. This is a full workflow. Now let me introduce our teammate Galen to talk more about the EKS tech details.
Thanks, Charles. Hello, everyone. I'm Galen from DevOps team. I'll give you guys a brief overview of Operator's backend architecture. Our backend server has been deployed into AWS EKS cluster for high availability, safe healing, and disaster recovery. The node group was selected as workloads of EKS cluster to ensuring our full access and control. The UAT environment and production environment were created in separate namespaces within the same cluster for centralized management and cost efficiency. We introduced the AWS load balancer ingress controller and external DNS controller as essential parts of the configuration to streamline routing and DNS resolution. This setup also enhances efficient traffic distribution, application scalability, and cost efficiency by sharing one application load balancer across different namespaces. The cluster autoscaler, horizontal port autoscaler, and vertical port autoscaler has also been configured in the workloads to ensure high availability, more responsive performance, and optimal resource utilization. The SonarQube server is hosted in a specific namespace within the cluster, following the principle of centralized management. Next part, our team member Shelton will present the implementation of our CI/CD pipelines. Let's welcome.
Hello. Hi, for our CI/CD, the pipeline initialized by pulling the latest version of our front-end application from our Bitbucket repository. We manage the application dependencies by executing the npm install command. For the develop branch, the pipeline will undertake a code analysis using SonarQube. Afterwards, the pipeline securely retrieves the environment variables from an S3 bucket. Following successful analysis and configuration, the pipeline initializes the build process. The pipeline uploads the application to the relevant S3 bucket based on the branch. Subsequently, it triggers a cache invalidation process for the CloudFront distribution, ensuring our users experience the latest changes in real time. For the backend pipeline, we deploy the develop branch to the UAT environment and conduct a code analysis using SonarQube for quality assurance. Also, we deploy the main branch to the production environment. Then the pipeline will create a Docker image for the application and push the image to ECR. Also, the pipeline retrieves the environment variable from the vault. Finally, the pipeline will execute the kubectl commands to deploy the application on the EKS cluster. Thank you.
Hi everyone. I'm Talia. I'm from DevOps team. I will talk about the IAC and the monitoring section. On the IAC part, we use Ansible to ensure and configure the Jenkins server by Ansible playbook. The coded approach can reduce errors related to manual setup, and we set up Jenkins slave servers to dispute workloads, promote parallel execution. Next, please. We use Terraform to orchestrate the deployment of front-end and back-end infrastructure. Through modularity, we enhance code reusability. And the Terraform workflow triggered by an automated Jenkins pipeline that facilitates fast and consistent builds. To enable collaboration, we use S3 for Terraform state management, which supports encryption and reduce concerns about storing sensitive data in the state fields. Next, please. The monitoring part, we build a foundational and virtual metrics and logging framework by integrating Grafana and CloudWatch. As shown in the screenshot, the Grafana dashboard provides real-time metrics for different aspects of the ELB. And vital statistics include host health, HTTP response codes, and potential exception, and are easily accessible. Next, please. We also monitor the behavior of EKS clusters, nodes, pods, and containers, including CPU utilization, memory consumption, and network traffic, and more. Further enhancing our monitoring, we set up custom alerts and are alerted in real time when any metrics deviate from expectations. This helps us accurate monitoring and the timely detection of any anomalies that require intervention. And that's all of our DevOps parts. Thank you.
Okay, now it's demo time. I will explain the entire system with 3 user scenarios, which can improve the a better understanding to our system. So first, let's assume that the business owner, William, he runs a cafe in both Sydney. And there is a 1-week promotion event that for any purchase over $10 can have a 30% off discount. And he wants to put that into database in order to let more local residents know the deal. Now, let's start with sign up a new account. All right, so he can register account. Let's do a fake testing. Let's enter some random data to set the password. And he lives in Sydney. Okay, now his account has been set. And William wants to update his profile so people know that's his official account. He can go up to first upload the user avatar. Let's see this one. And you can change the name to the Rusty Rabbit Cafe and a phone number. We randomly tapped on. Okay. Now the information has been saved, the profile has been updated, and now William can post a new record into database. Okay, let's say we have a make some post title, copy and paste. Here, he can upload up to 4 images. Say that's 1. That's 2, 3. Oh, and we also add the image crop feature. Say I can crop the feature like this. That's what I want. And I want to keep this image in the original size, and this one too. Okay, and that's what I want. And also, let's assume William has a video. He uploaded to YouTube, so he wants more people to see the video. It's a good way for advertisement. So he can do like this, and set the expire date. Say 1 week later. Let's say the event ends on 29, and it's food beverage. And the address, let's say he lives in Blue Plaza. The address will be auto-completed by using Google Map API. That's it. We submit, and you can see that's what he has here. He got the gallery, and that's a video he created. The more people can see. That's the dynamic map generated according to his address here. Now, Let's log out. Let's talk about the second user scenario. Let's assume that someone lives also lives in Bold. He's a local resident, and he's using this application for information collection. As I presented before, we provided a completed filter and a search function. So if we don't use current location or my subscriptions, then the search result will include all data from all suburbs of Australia nationwide. And the user can input keywords or specific industrial category for data filtering. Let's say I want to check on supermarkets and retail. We got the different items. And he can also manually input a suburb, which like here, I want to check all details in bold. And we only see the required data. And if user want to check the use current location checkbox, which will get his current location information, and by search, the result will only display all the information on the bold suburb. And if we check my subscription, that is we'll check all the data. This account subscribed. So if we didn't log in, we click on here. It doesn't work. You need to log in first. So we log in with Google for quick testing using my email address. Okay. Now, then I check what I have subscribed. That's a 2 business new post that I subscribed. And I can, if I don't want to subscribe those users, very simple, unsubscribe, unsubscribe, unsubscribe. Now it's all clean. And since we did enough efforts on the image optimization, you can see the page loading speed is really fast, like really good user experience. That's all. And the third user scenario is if we have assistant administration, right? So we want to admin to manage all the post records here. So we can do, we log in with identity. And then we have a list here. So we can check the user list, the post list, and the order list. Let's start from user list. We can search for one specific user. Let's say right? So if we find this user and we want to deactivate him, very easy. Now this user can't log in. And for the post list, if we see some posts we don't want to see or we don't want people to see in our database, we can simply deactivate it, and the record will gone. Let's go back to check. See we deactivate the Rusty Rabbit Cafe promotion, right? So we check. No more, it's gone. Okay, that's the main features. And thank you. Any questions?